Hello guys, and welcome to this video. It is about arc lengths and area of sectors, which means we will be dealing with circles again. I know it's been so long since we dealt with them last time. Alright, there are actually two equations in this section. You have arc length and then sector area. Okay, so two different kinds of sections, although, like all the other formulas, they do have a bit of logic to them. So the first one, when you're dealing with arc length, okay, we have arc length, which means we are talking about how long the arc is. Okay, so in the last chapter, we talked about the degree of the arc. We didn't actually talk about how long it was from point A to point B. Now we are. Now, the bit of logic that comes with this formula is that the arc is a part of the edge of the circle, which means it's a part of the circumference. So when you're solving for it, it's going to be x over 360 times the circumference. So that's going to be times 2 pi r. Okay? Now remember, keep pi as a symbol in your answer, which means you can almost treat it like a variable. But whatever you do, please don't multiply by 3.14 or use the symbol in your calculator or anything else unless the instructions tell you. Okay, we'll go over a few questions or examples later of when you have to use pi as a number. But for right now, leave pi as a symbol in your answer. Okay, the last one, or the next one, whatever one you want to do, sector area. Okay, now sector area is everything in here. Okay, I often refer to this as the pizza problem for no other reason than this looks like a piece of pizza. Now, sector area is always going to refer to the sector that x is in. So notice how x is my angle right here. Therefore, I'm talking about this arc and this sector right there. And this is going to be same thing as last time, x over 360, but times the area. So times pi r squared. Right. So as you can see, both equations start out the same. It's x over 360. The only difference is one is times the circumference and the other is times the area. Let's do some problems. Now, in this one, we want to find the length of arc MN. So that's this bit right here. And the area of the sector. Now, the instructions say a sector, so we're going to find the area of the shaded region. But it does ask for the length of arc MN. And I know it's that one because that is how you annotate a minor arc. So the length of the arc is x over 360 times 2 pi r. Now thankfully I already know what r is, but now I need to know what x is. So in order to do that, I'm just going to subtract from 360 in order to figure this out. So 270 minus 360, or the other way around actually, is going to give me x is equal to 90. So now I have 90 over 360 times 2 pi times 12. Okay, now there are a lot of different ways you can simplify this over here. Typically, I like to take care of my fractions first and just get smaller numbers. But you can do what you like. All right, as a reminder, whenever you multiply a whole number by a fraction, you multiply to the numerator. So this can be rewritten as 24 over 4 pi. All that simplifies down to 6 pi. And that's what I write over here, 6 pi. As you can see, pi remains a symbol in my answer. All right, now for the area of the sector, we're going to find the area of the shaded region over here. So that's going to be x times 360 times pi r squared. And if you're asking how do I know this, I'm solving for this sector, typically you want either the shaded region or the area the angle is in. Okay, now the difference between the first problem, the arc, and the sector is this one specified again, and this one just said area of a sector, okay, which means the shaded region. Now my radius stays the same, and I am already given x, so I can just plug straight in. So I have 270 over 360 times 12 squared pi. As you simplify, you get 3 over 4 times 144. Okay. And I am going to simplify 4 and 144 to give me 36 over here, which 36 times 3 is 108 pi. And those are my answers. Okay, for this next one, you go ahead, try to solve on your own, and when the video plays again, you'll see your answers. Okay, and here we go. Now, this problem started you off in a different spot, so if you're a little confused at first, that's okay. You were asked to find the length of arc xy. Okay, so if you remembered the correct equation, excellent. But you probably got about right here when you realized that you didn't have the radius. And so then you look back at your problem and you see they give you the area, and that should have connected in your mind that you had to use the area in order to find the radius. Now, looking at my area, I see a big long decimal and I do not see the symbol of pi. This means that this is one of those problems where pi becomes a number within the problem, because we have to find the radius, which means that eventually we're going to have to divide by pi. When you use pi as a number in your problem, use the symbol in your calculator. That will give you the most exact answer. If you are using a calculator that does not have the symbol, then you need to take pi out to the 4th decimal place. That way you get an exact answer. Okay? But otherwise, once you divide by pi, you then take the square root of both sides in order to find the radius, which gives you 11.4536. Again, remember, 4th decimal place until you're ready to box your answer. Now that we have our radius, it can be plugged in at the top, and we solve down. Now, once we're solving for the length of our arc, I now no longer need to use pi as a number. It is now back to being a symbol. So we only use pi as a number when we absolutely have to. And honestly, the reason is there's about 3 different ways you can calculate for pi, and that just gives us 3 different kinds of answers, if we're lucky. So whenever possible, we leave pi as a symbol in our answer. That way our answer stays as exact as possible. Okay, if you have a question on how I solved this problem or any other just general questions, please let me know. Otherwise, though, this is the end of the video. These are the 2 types of problems you're going to see. As always, there will be times where you're given what you need, or, as in this problem, you could be given what you don't need, and you have to find what you need. Okay? Please maintain a flexible mindset and be able to juggle the prior knowledge of the circumference equation and the area equation in order to find your radius. That's it. I'll see you in class.